Next, we come to talk about diffusion algorithm, which is given by the following formula. It's very scary, right? But actually, if you understand it from numbers, it may not be as scary as you think. Now, for example, like if you are talking about division of 47 divided by 3, you choose 1 and it's 3. So it's 70 remained. You choose 5, which gives you 15 in the product, and the remainder is 2. So you can write in two ways. One is 17 divided by 3 is equal to 15, remainder is a 2. But the other way would be you can look at 15, 3, and 2 and write as 47 is 15 times 3 plus 2. Actually, this is what you will say called division algorithm. So when you are talking about polynomial, like when you have it on the right hand side, a polynomial px is divided by x minus a, and then so as a result you have a quotient qx. And now because the divisor here, it is power 1, so that's why remainder here will be a number without any exit, or simply you can say it's a constant. So that's why you can see there's a difference between the notation. Quotient is something about xc, so that's why we use the function notation qx, while remainder here is a constant, a number, so that's why we just simply use r. So can you match with now, so this is the diffusion algorithm, x minus a times qx, and then plus r afterward. Now take a look on maybe one example which shows you how we use the diffusion algorithm. And let's take maybe like the second one. So in order to write diffusion algorithm, you can't avoid to do the division again. So it's x cubed 5x squared minus 4x plus 9 divided by x plus 1. So please pause the video for a short while, a few minutes, until you complete the division. Okay, at the time you did hard on the question, finish the question as well. And then you will see that now you have a divisor, x squared plus 4x minus 8, which should be multiplied to x plus 1 to form the first part in the division algorithm, while you have the remainder 17 to be added up at the end. So this is the format, or this is the answer of the division algorithm. The other situation you may see in the question will be like example 10. So it tells you a certain polynomial, so that means it's an unknown, which is divided by 3x squared plus 5x plus 2. It gives you the quotient and remainder. Maybe I use two different colors. Quotient 3x minus 1, remainder is a 5. So that's why the polynomial will be written as is divided by 3x squared plus 5x plus 2. So that's why it should be multiplied to the quotient 3x minus 1 and add up the remainder, which is a 5 in the question. So please don't just pause it here because you have to expand it in order to get the answer. You take a few minutes, or maybe take a minute to do it. And now I just simply write to the answer, which is 9x cubed plus 12x squared plus x plus 3. And another question which is a bit abstract, that means it's not just talking about calculation, but it's checking about the concept. It's quite abstract. And it tells you x plus 1 is a factor. Can you see that the word factor appears in the question of fxc? And now you are going to see which of the following must be a factor of fx plus 2. As the question shows you no information about the quotient, fx, or remainder, so and so, and then you can't do any calculation over there. As a result, division algorithm may be helpful in this situation. Because division algorithm will be telling you that fx is divided by x plus 1, which is a factor, so that's why there should be a quotient over there. So the meaning of factor means that the remainder is equal to 0. So that's why you see there's nothing at the end of the function. So as a result, this is the kind of a formula for fx. Well, when you are going to talk about fx plus 2, so you have to do the substitution accordingly, which is xc, okay, x plus 1, qx. So at the spot, you have to change the change the expression accordingly. So you have fx plus 2 plus 1, and then q, which is x plus 2. Actually, we never know what is qx plus 2 nor qxc, because we don't know what is fx as well. You don't know qx or qx plus 2, whatever. But the point is, when you continue to simplify the expression, And you have now fx plus 2 equal to x plus 3 times qx plus 2. Regardless of the value of qx plus 2, can you see that x plus 3 is a factor because there is no remainder at the tail? And that's how we get the answer D in the question. This is the end of the parts talking about division algorithm. Generally speaking, I can say the algorithm or kind of the formula, it is helping you to write down kind of precisely what is your polynomial, what is fx is. And that's why example 11 gives you a very good demonstration.